Ever find yourself wading through a mountain of education research?
Oh, absolutely.
Just like, desperately searching for that clear, practical advice, like what actually works.
Yeah. Yeah.
Trying to sift through it all, prescriptive statements, as the experts call them.
The shoulds, right?
Yeah, get the shoulds. What research suggests we should be doing in the classroom? It can be, well, overwhelming.
Definitely. A real maze.
So for this deep dive, we're focusing on a powerful tool that's becoming more and more common in education research: structural equation modeling.
Ah.
Yeah.
Oh.
And we're going to explore how it can help us get closer to making those reliable prescriptive statements about what really makes a difference in education. Our main source here is the article, Prescriptive Statements in Educational Practice. What can structural equation modeling, SEM, offer?
Great article.
Really insightful. And the big question we're tackling today is, when and how can we confidently use research that uses SE to inform what we do in education?
That's the core of it, yeah.
Because at the end of the day, this isn't just about complex statistics.
Right.
It's about you, the listener. Whether you're prepping for a meeting about new teaching methods or just fascinated by, the science behind learning, grasping what TEMIN can do and what it can't do can help you cut through the noise.
Absolutely.
And find those more dependable, data-driven insights. So SM,
Yeah.
the name itself can sound a bit intimidating.
A little bit.
In simple terms, what is it?
It's funny. The name might sound technical,
Yeah.
but the basic idea behind SEM is actually pretty intuitive.
Okay.
Think of it as like a way to understand how lots of different factors are connected within a complex system. It's not just looking at one relationship in isolation. SM combines things from regression, how one thing predicts another,
Okay.
and factor analysis, which is grouping together measurements that seem to be measuring the same underlying thing.
So instead of just looking at a simple cause and effect, like, more reading equals better vocabulary,
Right.
SEM could consider reading, but also a student's background, their interest in the subject, even, the resources in the classroom,
Yeah.
and how all of those things together influence vocabulary growth.
Exactly.
Right.
And what makes SIM really valuable in educational research is its ability to work with things we can't directly measure.
Okay.
These are what we call latent factors.
Interesting.
Think about like a student's self-efficacy or their level of curiosity. We can't directly measure curiosity, right?
Right.
But we can observe things like their persistence on challenging tasks, their willingness to try new things, how confident they say they are. SEM lets researchers construct these latent factors based on multiple observed indicators.
So it's kind of like trying to understand like a really complicated machine,
Yeah.
not by just looking at one part,
Yeah.
but by observing how all the different parts work together,
Exactly.
including those inner workings, that
Yeah.
you can't see directly.
Yeah.
But you can kind of infer from how the machine performs as a whole.
Perfect analogy. Now, why is this approach so useful?
Yeah.
When we want to make prescriptive statements.
Right.
When we want to say, hey, here's what you should be thinking about doing in your educational approach. The article highlights a few key benefits.
Okay, let's hear them. What's the first one?
One major advantage is how SM deals with measurement error.
Measurement error.
In the real world, the ways we measure things, they're never perfect.
Right.
There's always some degree of unreliability.
Like a test doesn't always capture everything.
Exactly. In our assessments, whether it's standardized tests or surveys, SEM can account for these imperfections
Okay.
in our measurements.
Interesting.
And by doing that, it gives us a more accurate understanding
Okay.
of the actual relationships between the things we're studying.
Okay.
So when SM shows that doing X leads to Y,
Yeah.
we can be more confident that this isn't just because our data was a little messy.
Right.
It's like filtering out the noise
Okay.
to get a clearer signal.
I like that. It's like tuning out the static to really understand what's going on.
Exactly.
What's another benefit?
Another huge plus is SEM's ability to test really complex models.
Okay.
Education is rarely simple.
Yeah, definitely not.
There are often so many factors involved,
So many.
and they can all influence each other in all sorts of ways. SEM lets researchers analyze a bunch of things at the same time.
Okay.
Predictors, things that might cause an outcome. Moderators, things that can change the strength of a relationship.
Okay.
Mediators, things that explain how a predictor influences an outcome, and of course, the outcomes themselves.
Right.
It can even look at these relationships over time, which is so important in education.
Yeah.
Because development and learning, they happen over weeks, months, years.
Absolutely.
It lets us look at the whole web of influences, not just a single thread.
So it can analyze this whole network of
Mm-hmm.
how things affect each other,
Yeah.
not just a single, cause and effect.
Yeah. Exactly. And because it can handle so many pieces of the puzzle at once,
Yeah.
findings from SEM studies often give a much more realistic picture
Okay.
of how complex education really is.
Okay.
And that can lead to more nuanced and effective prescriptive statements.
Okay, so it's more accurate and more comprehensive. What else?
SEM also lets researchers directly test how well their model actually fits the data they collected.
Interesting.
There are these statistical measures, we call them fit indices,
Okay.
that tell us how closely the model lines up with the real-world data.
Right.
If the model shows a good fit, it gives us more confidence that those relationships the researchers are proposing are actually there in the real world.
So it's not just about finding relationships, but also checking if they actually hold up when you look at the data.
Exactly.
That seems crucial if you want to make recommendations that people can trust.
Absolutely. And then there's SES power when it comes to analyzing longitudinal data.
Longitudinal data. Okay.
Data collected at multiple points in time.
Right, right.
The article really stresses that this might be one of SEM's biggest strengths for making prescriptive statements.
Oh, okay.
Because when we can see how variables change and influence each other over time, we get much stronger evidence to say that one thing really causes another. We can see the sequence of events, the cause leading to the effect over time.
We see the progression,
Yeah,
the cause leading to the outcome as time goes by.
exactly.
Yeah.
Rather than just a snapshot at a single moment.
Right, single observation. Okay.
Longitudinal studies with SIM can help us figure out if a model stays consistent over time, understand how processes unfold, and pinpoint the direction of influence between variables.
Like which one is causing the other,
Exactly.
or if they're both influencing each other.
Precisely. Like, does student engagement lead to better grades?
Yeah.
Or do better grades lead to more engagement?
Or is it both?
Or is it both?
Okay.
Longitudinal SIM can help us untangle those dynamics.
All right, so analyzing data over time
Yeah.
with SEM
Yeah.
seems to be like a really solid foundation
Yeah,
for informing those prescriptive statements.
absolutely.
Now, the article dives into different types of longitudinal designs.
Right.
Let's start with correlational designs.
Okay.
What can SM tell us from those?
So with correlational studies, remember, we're looking at relationships between variables without actually changing anything.
Right, no intervention or anything.
Exactly. No treatment, no control group. But longitudinal semia can still give us valuable information
Okay.
by looking at patterns over time.
Oh.
One key concept here is autoregressive paths.
Okay, that sounds complex.
It's basically looking at how a variable at one point in time predicts itself at a later point in time.
So how stable something is over time.
Exactly. Like, how does a student's enjoyment of reading in the fall predict their enjoyment of reading in the spring?
Makes sense.
Tracking consistency over time.
Okay.
Then we have cross-lag panels.
Cross-legged panels.
These take it a step further. They look at how one variable at one point in time predicts a different variable later on, and vice versa.
Interesting.
The example the article gives from Martin and Liam's study on personal best goals, or PBs, and achievement.
Yeah, I remember that one.
That's a great illustration.
Right.
They used SEM to see whether setting personal best goals predicted later academic achievement more strongly than past achievement predicted later goal setting, or if there was a back-and-forth relationship.
Okay.
So when you're looking at research on achievement,
Mm-hmm.
pay attention to studies that examine the direction of influence.
Right.
Does factor A lead to factor B, or is it the other way around?
Yeah.
That nuance can really change how we think about interventions.
And what did they find? Did they find that, emphasizing those personal best goals had a bigger impact?
Generally, yeah.
Okay.
They found that focusing on personal bests had a stronger effect on later achievement.
Okay.
But there were also some cases of that two-way interaction.
Interesting. So it suggests different advice you might give students, right? Like focus on striving for personal improvement, not just your past results.
Exactly.
If it was mostly the other way around, then maybe the focus would be more on, rewarding past success.
Right.
But the SIM analysis showed a more complex picture.
Yeah.
It suggests that encouraging a focus on personal growth goals could be really important for boosting achievement.
Absolutely.
The article also mentions latent growth modeling.
Right.
What's that all about?
Latent growth modeling lets us see how individuals and groups change over time.
Okay.
It doesn't just give us an average trend.
Okay.
It can reveal different patterns of change within a group
Yeah.
and identify factors that might be influencing those individual growth trajectories.
So like different paths people take.
Exactly.
Yeah.
The example from Muthan and Ku's work on achievement trajectories
Yeah.
showed how AVE could uncover differences, like those related to gender,
Okay.
that might be hidden in simpler analyses that just look at the group as a whole.
So you might miss those important nuances.
Exactly. We can see not only that achievement is, say, generally improving, but how it's improving for different subgroups
Okay.
and what might be driving those different rates of growth.
That's really helpful for, figuring out how to tailor teaching strategies to different groups of learners.
Absolutely.
Then there's intensive longitudinal data.
Yes.
That sounds very, very detailed.
It is. This is where we're collecting data much more frequently,
Okay.
sometimes even in real time,
Wow.
using tools like electronic diaries or physiological monitoring.
Okay.
SEM can analyze this kind of data to understand really complex individual patterns of change and how different things relate to each other within a single person over time.
Wow.
Imagine tracking a student's engagement throughout the school day
Yeah.
in relation to different classroom activities,
Okay.
or even their physiological responses. SEM can help us understand those intricate dynamics within a single person.
That seems like it could give incredibly detailed insights into, the actual process of learning.
It can. And finally, with longitudinal correlational designs, the article points out that SEM can even model measurement parameters over time.
Okay.
For example, researchers can account for method effects.
Method effects.
These are biases that happen because of the way we measure things.
Okay.
By correlating the unique parts of the same measurement taken at different times, this helps to get less biased results.
Interesting.
They can also test for something called measurement invariance
Measurement invariance.
to make sure that the way we're measuring a concept isn't changing over time. It's like making sure the ruler we're using to measure student progress stays the same length.
Right. It's got to be consistent.
Exactly. If the ruler changes, we can't accurately compare measurements from different times.
It's like, if the test is changing what it's measuring,
Right.
you can't really compare the scores from one time to another.
Precisely. This is super important for making valid comparisons across different time points.
Okay, so even with just correlational data,
Yeah.
longitudinal SEM offers a really sophisticated way to look at relationships and influences over time,
It does.
leading to, more informed possibilities for practice.
More informed, but still cautious.
Of course, always cautious. Now, what about quasi-experimental designs?
Right.
Those are the ones with treatment and control groups, but without random assignment, right?
Exactly. They often happen in more real-world educational settings.
Okay.
The article talks about how SEM can make the analysis of these designs much stronger
Okay.
by including latent factors and using modeling techniques that reduce bias.
Okay.
SEM can provide stronger evidence, even when we don't have the perfect control of random assignment.
The article gave some good examples here, like studying the impact of changes to an entire school system or the effects of dropping out of school.
Right.
How does SEM strengthen those kinds of studies?
So in those situations, random assignment often just isn't feasible or ethical. SEM allows us to statistically account for pre-existing differences between the groups
Okay.
by including what we call covariates.
Covariate.
These are other factors that we measure and statistically control for
Okay.
to try and even the playing field between the groups.
So even though in the real world it wasn't perfectly controlled,
Yeah.
you're trying to statistically make it a bit more fair.
Exactly. For example, if we're studying a change to a school system, we might use S to account for differences in things like prior student achievement or socioeconomic backgrounds between schools that went through the change and those that didn't.
Right.
This helps us isolate the effect of the change itself.
So it's like statistically evening out the starting point,
Yeah.
even when you couldn't randomly assign people to groups.
Precisely. The article also talks about interrupted time series sum design.
Interrupted time series, okay.
These are used to analyze the impact of an intervention, like a new policy. by looking at trends before and after it was put in place.
Okay.
And it highlights how quasi-experimental designs often look at effects over longer periods,
Okay.
which is more realistic than some tightly controlled experiment.
Right, because in the real world, things take time.
Exactly.
It's
It also mentions accelerated longitudinal designs,
accelerated longitudinal.
where you test different age groups over a shorter time, which SEM can also analyze effectively to get a broader view of development.
Okay, so even when you can't do a true experiment,
Right.
SEM offers a way to analyze those real-world interventions and changes.
It does.
Now, what about experimental designs? The ones with random assignment that are like the gold standard for figuring out cause and effect.
Yeah.
Does SEM have a role to play there too?
Absolutely. While traditional statistics are usually used for analyzing experiments, the article argues that SEM can be really useful even with smaller sample sizes. Russell and his colleagues make some important points about the limitations of those traditional methods. They point out that they often don't account for how unreliable our measurements can be, especially for the dependent variable, the thing we're trying to change.
So if our test isn't perfect,
Right.
we might miss a real effect of the intervention.
Exactly. SEM can address this by estimating the dependent variable as a latent factor based on multiple indicators,
Okay.
which corrects for unreliability and gives us a more accurate estimate of the treatment effect.
Okay.
The second problem they raise is correlated measurement error, especially when we're using the same test before and after the intervention.
Okay.
SEM can deal with this by modeling that shared error variance so we can better see the true effect of the treatment.
So even in a well-designed experiment with random assignment,
Yeah,
SEMSync can still offer a more precise analysis
it can.
by accounting for those imperfections in how we measure things.
Exactly. And the article mentions how latent growth modeling can be used in experiments, too. Okay. To track different developmental patterns depending on the intervention. The example they give of that aggression intervention, that only worked for kids who started out high in aggression.
Right.
Really illustrates this well. SEM let them uncover these subtle effects that might have been missed with simpler analyses.
So sometimes a program or an intervention might only work for a certain group.
Yeah.
And SEM can help us figure out who that is.
Precisely. Now, the article also talks about cross-sectional sanction,
Cross-sectional.
where the data is collected all at one time.
Right.
Given all we've talked about with the power of longitudinal data,
Yeah.
what can we really say about prescriptive statements based on cross-sectional SAM?
Good question.
It's important to be clear here. The article says outright that it's much harder to make solid prescriptive statements based on cross-sectional data alone.
Okay.
It can, however, offer what it calls prescriptive possibilities and inferences.
So more like hints at what might be worth exploring.
Yeah, potential directions, rather than definitive recommendations.
Not like, this is what you absolutely must do.
Right. If a cross-sectional study has a strong theoretical foundation, uses the right control variables, has a large and diverse sample, good measures, and shows meaningful effect sizes, then we can start to think about possible implications for what to do.
Okay.
Practitioners might carefully test out these possibilities.
Right.
And researchers can then do follow-up studies over time to see if those initial ideas hold up.
So it's more like a first step.
Yeah.
It can point us in a promising direction.
Exactly.
But we really need that longitudinal research to back it up
Absolutely.
before we can make strong recommendations. Now, before we wrap up,
Yeah.
the article does mention some limitations and cautions with SM.
Important to keep those in mind.
What are some of the key things we should remember?
One thing is that SM hasn't been used as much in experimental studies,
Okay.
and there's a need for more people to realize its potential there. Also, SEM, especially for complex models, needs enough data
Okay.
to reliably estimate all those relationships, which can be tough in experimental research.
So you need a big enough sample size
Yeah,
to really be confident in those connections you're seeing.
exactly. The article also notes that SEF is statistically complex, and you can run into problems with estimation and model fit if it's not done right.
Right.
There's also the risk of missing important variables.
Ah, leaving things out?
Yeah, things that could be influencing the results. And there can be some subjectivity in interpreting the findings, like relying too much on those general rules of thumb for what's a good model fit,
Right.
which might not always be right for every situation. Just because a model fits the data statistically doesn't necessarily mean it's the best explanation.
Or the only one.
Or the only one.
Okay.
A good model fit doesn't always mean it's explaining a lot of the variance in the outcomes either.
Right.
And there might be other models that fit the data just as well, or even better. And finally, this is really important, SEM can't fix a poorly designed study.
It's not magic.
No, it's not magic. Even the most sophisticated stats can't overcome basic flaws in the research design.
Like if you measured things at the wrong time or something?
Exactly. A solid research design, strong measures, and a sound theory are still absolutely essential.
They're the foundation.
Yes. SEM is a powerful tool to enhance our understanding. It's not a magic wand.
It can build on that foundation.
Mm-hmm.
But it can't replace it.
Precisely. Longitudinal SEM, when it is built on that strong foundation, gives us incredibly powerful ways to develop those confident prescriptive statements.
The shoulds.
Yeah, the shoulds. Its ability to handle complexity, account for measurement error, and analyze change over time makes it really valuable.
Okay.
Cross-sectional SEM can give us some initial insights, but those should be seen as possibilities that need more research. Longitudinal research.
So for you, the listener, remember that even though SEM is a complex statistical technique, understanding its main ideas can help you be a more critical consumer of educational research.
Absolutely.
You can start to spot findings that are based on solid methods and are more likely to actually work in practice.
It's empowering. And this brings up an interesting question for you.
Right.
Think about those areas in education where you've seen conflicting advice or recommendations. How might the principles of longitudinal research and the careful use of statistical tools like SEM help bring more clarity to those areas in the future? Start looking for research that looks at changes over time and considers how different factors interact.
Yeah.
It could lead to a much deeper understanding of what truly works in education.
It could.
Yeah.
Food for thought. Thanks for joining us for this deep dive.
It's been a pleasure.